to another week in Middle School Math 3. We are going to be starting a new chapter, chapter 11. For this chapter, you may notice that there are no notes to print out. That is on purpose. What you'll need is some paper, whether that's notebook paper. I would recommend lined paper. If you don't have it, you can use printer paper or whatever paper you have, but get that out, take notes, and compile them. We need to be keeping them together so that let me adjust this quick. So that when we have a quiz or something like that, that we have notes to use on that. And they can be a really good resource to look back at as well for our homework. So grab paper, you'll be ready to go. There are 4 assignments that you'll print off. Or if you don't have a printer, remember you'll just do it on paper. Based on what you're seeing online. The other thing you'll notice with this video is that it is one video. I put everything you need for the week in one video. Now, you might think, well, then I just have to find the place from the day before. No. If you go down below the video on YouTube, they have that description box, and in there, I have time-stamped everything, so I put the time, so like Monday, it'll have the times for that, so you can just click on those times, and it'll jump you to that part in the video. The other thing that I'm doing a little bit differently this week is with one big video, within each day, I've also time-stamped within some of the days. So, I've kind of broken it down into pieces, the lesson. So if you are struggling with a certain type of problem in your homework, you can go back and just look at that part of the lesson, okay? So make sure you're using that description below with those timestamps to jump you to parts in the video. So you guys have 4 homework assignments and you have 3 lessons. Friday will be a review day. So there's 3 days of lessons within this video, and I'll see you later. Have a good week. Bye. All right, today we're in 11.1. As I said in that intro, you are going to be taking notes on your own paper. So grab notebook paper, printer paper, copy down our heading today, 11.1 comparing. Make sure you're keeping track of these notes. And we are going to start with our first section, section A. I divided these lessons into sections just to keep track of them, and so you could refer to them at different times. Okay, so get that copy down and then we'll get started. And I'll see if my... Okay, so in this first section, we are going to locate -4, 0, and 2 on the number line. Now, first of all, I want to let you know we are going to be working with negatives. We're going to learn a special name for negatives, positives, and 0, but not yet. Before we get there, we are going to locate these numbers on the number line. Now, first of all, we need a number line. Now, the number line includes all numbers up to 1,000 and 1,000,000 and all over the place. But for -4, 0, and 2, we're going to create a number line that fits those numbers on it and the ones in between, okay? We won't just put -4, 0, and 2. So draw a straight line, follow along, arrows on both ends, and now we're going to fill this number line out. So we'll put, I'm going to put 0 in the middle. It doesn't have to go in the middle. And then we're going to put numbers evenly spaced beside that. So up from 0 is 1, then 2, then 3, 4, and in the other direction, -1, -2, -3, and -4. So we have our number line. Now, here's what I have a lot of students do. They see -4 and they circle it. That is not plotting the point, okay? To plot the point or to locate it, we need to actually put a point on that number. So for -4, we're going to come over here to -4, and we are going to put a point right here. We have now located -4. Now we're going to do 0, and we're going to locate 0 right here. And lastly, 2. And that is graphing on the number line. All we simply do is draw a number line, fill it out, make sure it's neat and straight, okay? That's important. And that we have these evenly spaced tick marks, and that we plot the point. All right, now we are going to practice changing word phrases into numbers, okay? So let's start with this first phrase. By the way, this is section B. First, loss of 3 yards. First of all, this is typically used in football, right? So if you're going in the wrong direction, you lose 3 yards, right? So if it was a loss of 3 yards, what number would we use to represent that? We would use the number -3. All right, what about a debt of $50? Think about what debt means, right? Debt means we owe somebody $50. So what number could we use to represent that? Well, since it's debt, we would say -50. All right, what about increase of 2 pounds? What number would we use to represent that? Well, increase would assume that it is positive, right? So do we put +2? No, this is not a number, all right? If it has no sign in front of it, we assume it is positive, okay? So we would just put +2, not +2. All right, and that is changing word phrases to integers. All right, now we're going to move on to a new definition, opposites. Opposites are two numbers the same distance from 0, but in opposite directions. So I'm going to show you how this works on the number line. Once we see it visually, I think it's going to make a lot of sense, and we won't need the number line every time. So let's look at, I want us to find the opposite of the number 3. What is the opposite of the number 3? Well, like I said, we're going to use a number line, and we're going to use the definition. So if we have a number line here, and let's locate 3 on the number line. So we have 3 right here, so we'll put 2, 1, 0, -1, -2, -3. Okay, so first of all, two numbers the same distance from 0. So 3, how far is 3 away from 0? Well, here's 0, here's 3. It is 1, 2, 3 units away, right? Not too surprising, but it's 3 units away from 0 to 3. Now, the definition says two numbers, the same distance from 0, but in opposite directions. So instead of going 3 this direction, what if we go 3 this direction? So 1, 2, 3. And do notice it's 3 in both directions, okay? You cannot go -3 units, it's 3 units. Distance is always positive, okay? On the number line, the number is negative, but up here we'll just say it went 3 units. So 3 units to the right, 3 units to the left. What is the opposite of 3? Well, if we go in the opposite direction, the same number of times, it is -3. So the opposite of 3 is -3. The opposite of -3 is +3. And do notice, again, we don't put that plus sign. It's positive if it has the no sign on it. So you may start to pick up on a rule. So what is the opposite of 1? Well, it would be -1. And the opposite of -2 would be 2, right? You're noticing that all we're doing is changing the sign. That is the opposite, okay? So the opposite of -20 would be +20. Let's throw a few examples up here. We'll put 3 examples here, and I want you to find the opposite of these. We'll give you a little bit of a practice. I want you to find the opposite of -16. I want you to find the opposite of 7 and the opposite of 0. Starting with -16. If we were at 0 and we went to -16, think about how far it would be, and if you went in the opposite direction, what would you get to? So the opposite of -16 is what? It would be 16. Okay, what is the opposite of 7? Again, we just have to change the sign, right? -16, the opposite is +16. +7, the opposite would be -7. Now, what about 0? Here's a tricky one. Well, let's go back to the definition. Two numbers, the same distance from 0, but in opposite directions. Well, how far away is 0 from 0? How far away is 0 from 0? Well, it's 0, right? So if we go in the opposite direction, 0 units, what will we end up at? 0. So the opposite of 0 is 0. We're going to get a donut there. So that is opposites. Okay, so I've used this word a few times today, but I couldn't give you this definition till now because you hadn't learned what the word opposite meant yet. And that was in the definition. So how could you understand what an integer was? So now you have it. So integers are whole numbers and their opposites. Integers are whole numbers and their opposites. So while you're getting that written down, let's start talking about what this means. First of all, whole numbers. This is the set of numbers that starts at 0, and then it goes on to the counting numbers, right? So we have numbers like 0, 1, 2, 3, and so on. I'm going to put a dot, dot, dot because it goes on forever, okay? 4, 5, 1,000, 1,000,000, right? Keeps going. Now, their opposites would be numbers. Now, first of all, what's the opposite of 0? 0. We're not going to list it twice, right? It's just 0. The opposite of 1 is -1. The opposite of 2 is -2. The opposite of 3 is, I gave it away, -3. And same thing on this side. It goes on forever in this direction. So -100, -1,000,000, -1,000,000,000, and so on. And we'll put these brackets around to make it proper. We'll learn more about that next year. And this shows us the integers. The integers include 0, and it includes negative numbers and positive numbers. Do notice that integers do not include fractions or decimals. So with that in mind, let's move on to compare. Here, let's compare. We have 9 and 5. We are going to start with problems you have seen before and work to problems you have not seen before. You have compared using greater than or less than, but you have not compared with integers. You've worked with whole numbers, but never negatives, okay? So, looking at 9 and 5. Again, this is a problem you have seen before. Which is greater between 9 and 5? Well, it is the 9, right? So the larger end of the sign will face this way. We would read this as 9 is greater than 5. And I'm going to get rid of this blank because this actually reads greater than or equal to, which is not something we've learned about before. So we'll get rid of that and just say 9 is greater than 5. Now, if you are unsure, you will use a number line. And this number line, I'm going to write it right now because it's going to come in handy for the rest of our time. So in this number line, I'm not going to write all the numbers in, but I'm just going to put a loose number line. So we have 0 here, 1, 2, 3, 4, 5, 6. Well, we got to go up to 9. 7, 8, 9. And you may want to put a number line at the top of your homework or at the top of your notes that you just used the whole time. And we'll also go in the other direction. -1, -2, -3, -4, -5. And if it's not big enough, we'll add more to it. So first of all, 9 and 5. You guys already know why 9 is greater than 5, but we're going to look at it on the number line so we can use these principles later. So if we have the number 9, we'd say it's right here, and the number 5 is right here. Which is greater? Well, we know 9 is, and we know on the number line, the further to the right, the greater the number, and further to the left, the smaller. So looking at the number, if we're looking at the numbers 5 and 9, 9 is further to the right, so it is greater. Okay, -6 and 8. Now, you could look at the number line, but you should have a principle that we can use just by looking. If we have a negative and a positive, we automatically know which is greater. And between the negative and a positive, right, because we have 0 here, positives go this way, negatives go this way, so which is greater automatically? The positive, right? Okay, and then -6 and -8. Now this is where students get stumped. They look there and they say, well, 8 is bigger than 6, so I bet this is the answer. But this is not 8 and 6. This is -6 and -8. So this is where the number line can be really helpful for you to visually see what's going on. So I'm going to extend this. This only goes to -5. So let's add in a little bit further. Remember, number lines have arrows on the end because they go on forever in both directions. But my camera doesn't go on forever in both directions. Okay. So -6 and -8. Here's -8. Here's -6. Well, -6 is further to the right, which means it is greater. And if you're getting confused, remember it's the opposite of what it would be if they were both positive. So if we had +6 and +8, then 8 would be greater. But since these are both negative, -6 is greater. It is closer to 0. It is further to the right. That is comparing. Last section of the lesson, ordering numbers. So we are ordering these numbers least to greatest. So instead of just taking two numbers and comparing them, we are taking a group of numbers and we are writing them least to greatest. Okay? So there's lots of different ways we can order these. If we were to graph these numbers on the number line, they would automatically get in line from smallest to greatest or least to greatest. We can do it that way. There's a lot of ways to do this. I'm going to start by picking the smallest number and the greatest number and then filling in the middle. Again, there's lots of ways you can do this. So looking here, the smallest or the least would be what? It would be -7, right? And if you weren't sure, I would draw a number line and locate these numbers. All right, so I'm going to cross it off so I don't duplicate or miss any. The greatest number here, we have 5, 0, 1, -2 would be 5. So I'll put that up here. And then I have 3 more numbers to fill in, so I'm going to put my commas here so I'm ready to go. All right, the next smallest number, well, we have 0, 1, and -2. By the way, 0, is it positive or negative? It would be neither, right? It would be neither. So we have something that's neither positive nor negative. We have something positive and we have something negative. So which one is smallest? The negative, right? And then which one is smallest next, 0 or 1? It would be 0, right? And then 1 is positive. And now we've ordered these numbers least to greatest. All right, that's your lesson for the day. Get after your homework, and I'll see you tomorrow. All right, moving to 11.2. 11.2 introduces the concept of absolute value. This is so important. I mean, it's a really important definition for us to understand. So the definition of absolute value is very simple. It is the distance from 0. Absolute value simply means distance from 0, and we're going to use the number line again today to help us with that. Absolute value is signified by these bars here. Notice they are straight up and down. They have no bracketing. They have no curves. They're just straight up and down. If we were to look at this right here with these absolute values and the 3 in between, we would read this as the absolute value of 3. That's what this symbolization means, the absolute value of 3. So with that in mind, let's find out what is the absolute value of 3. And you're going to use a number line to do this. Now, will you use a number line in all of your homework? No, you won't need to, but it can help us understand what's happening here. So looking at our number line, we need distance from 0, so I'm going to put 0 on there. And I'm going to put 3 on there, so I'll put the numbers in between as well. So how far away? Distance from 0, right? How far away is 3 from 0? Well, we did this problem yesterday, looking for opposites. 3 is 1, 2, 3 units away. So we could say that the absolute value of 3 is 3. Okay, what about another one? What about if we try this? What about, instead of absolute value of 3, absolute value of 3 is 3. What about the absolute value of -3? So let's draw another number line. So if I have my number line here, and we'll put 0 on there. Now we could fill in to the right. We can put 1, we can put 2, but we really don't need 3. We're looking for -3. And we're going to model that through the number line. So 0, -1, -2, and -3. Well, how far away is -3 from 0, right? Because the definition for absolute value is the distance from 0. So what's the absolute value of -3? Well, that's how far away -3 is from 0. So if we go from -3 to 0, how far is it? It's 1, 2, 3 units away. And I want to emphasize this. Yesterday we talked about this. Can distance be negative? No. So it's not -3 units away. It is 3 units away. So the absolute value of -3 is 3. So absolute value, I'll pull the other problem up here. Absolute value of 3 is 3. And absolute value of -3 is 3. So they're both 3 units from 0. Okay, let's get rid of all of this and let's try and practice some more. I think we're going to start to notice a pattern that'll help us. What about if I say find the absolute value of -7? Well, remember the definition for absolute value is distance from 0. How far away is -7 from 0? You guys can draw a number line if you want. You don't have to, but I'm going to at the beginning here so you see it visually. Okay, so 0's here, right? -7 is to the left. It's going to be over here. We'll fill in. Oh, that wasn't great. It'll do the purpose right now. So how far from -7 to 0? Well, it's 1, 2, 3, 4, 5, 6, 7 units away. So the absolute value of -7 is 7. Are we starting to notice a pattern here? Now, let's do one more and then we'll talk about the pattern, okay? What about the absolute value of 2? The absolute value of 2. Okay, the definition for absolute value is distance from 0. So maybe we don't even need a number line for this. How far away is 2 from 0? It is 2 units away, right? So what pattern are we seeing? Well, it's taking every single number in here and it is doing what to it? It's making it positive. If it's positive, it stays positive. I have a lot of students, a common mistake is to make it negative, but that's not what the definition says. It says distance from 0, which means that it would be positive. And here's really where we can think about this. Distance, I told you, is always positive, right? You cannot walk a negative mile, right? Even if you walk it backwards. If you walk backwards for a whole mile, do you say I walked a negative mile? No, you walked 1 mile, but you walked it backwards, okay? So, absolute value of a number is just that number, but positive, right? The distance from 0. So the pattern we see here is that it makes negative numbers positive and that it takes positive numbers and keeps them positive. So let's do just a couple more practice problems and then we'll move on to combining these into other problems. What if I give you the problem, absolute value of -21? How far away is -21 from 0? Well, it is 21 units away, right? Or we know that the absolute value bars makes that number positive. What about the absolute value of 0? We know the definition for absolute value is distance from 0. How far away is 0 from 0? It is 0. Last one before we move on to our next section. Our next half of this section, I should say, absolute value of 55. What is the absolute of 55? Remember the definition, distance from 0. How far away from 0 on the number line would 55 be? Well, it would be 55 units. All right, with that, let's move on. A few problems where we mix absolute value in with other operations. Now, I will let you know, in order of operations, absolute value bars are treated like grouping symbols or parentheses, right? So that's what we deal with first. So looking here, we have the absolute value of -6 plus 5. So we're going to deal with these absolute value bars and then deal with the addition, following order of operations. What is the absolute value of -6? Well, we know -6 is how far away from 0, right? The definition for absolute value is distance from 0. How far away is -6 from 0? It is 6 units, right? So we have 6, and we'll bring down the plus 5, and we know 6 plus 5 is 11. Let's try another one. Okay, copy this example down. Again, we have absolute value bars in there. We have this dot here means what? Multiplication, and we have subtraction. So we're going to follow order of operations. We said that absolute value bars should be treated as grouping symbols, so we deal with those first. The absolute value of -2 is 2. We'll bring that down. And this was out front, okay? It was not included in here, so we will bring this down. This we already used up. We found the absolute value of -2, so this whole thing goes away. We'll bring down the 4 and the times sign and the 12. Now, following order of operations, what should you do next? Choose carefully. We have multiplication, we have subtraction. Multiplication comes first. 12 times 4 is 48. And bring down the -2. Notice how I'm showing each step. This is what your homework should look like. Show me your work. Show one step at a time, line by line. 48 minus 2 we know is what? 46. And box or circle that answer. And that's simplifying. Let's do one more example. Looks a little bit different. There's not a lot going on, but we'll take what we get. So we have this negative or subtraction sign, and we have absolute value bars. Well, we're going to deal with the absolute value bars first. The absolute value of 12. Now, this is not included, so we'll be ignoring that. Just the absolute value of 12. What is the absolute value of 12? Well, how far away is 12 from 0? It is 12. Now, did we use this sign yet? No. All we've taken care of is the absolute value, so we'll bring the sign down, and we cannot simplify any further, so our answer is negative 12. And that is our lesson for today. I'll see you tomorrow. All right, we have made it to 11.3. This is the last lesson of the week. You guys do have a review section tomorrow, but it's not anything new, okay? So this is your last new lesson of the week. What I want to start with is a little story, and hopefully this helps us remember. I wouldn't even say a story. Don't make it into too much, okay? So let's say we have a situation, okay? In this situation, we've got kind of a battle scene going on. All right, we have 10 good guys, okay? So we have 10 good guys, and we have 6 bad guys. Based on what you know, who's going to win, the good guys or the bad guys? Well, we would say the good guys have more, so I would say the good guys are going to win, right? By how much do you think the good guys are going to win? Well, or how many more do they have? Well, we would say 4, right? Now, we use this bad and good scenario to help us learn about addition. Today, we will liken the positive numbers to good guys, and we'll liken the negative numbers to bad guys, okay? And sometimes this can kind of help us get it in our mind. So let's look at this as if this was a problem. So instead of using good and bad, let's use positives and negatives, okay? So 10 good guys would be 10 positive, or positive 10. Plus, because we're learning about addition today, we have 6 bad guys, so we would write that as negative 6. Now, we can't have these two signs stacked up on each other, so you'll notice today that we use parentheses. Okay, so this says, if we were to read it, 10 plus negative 6. Okay? Now, first of all, I'm going to draw a little diagram to help us think about this, okay? This is a positive 10, okay? So what I'm going to do is I'm going to draw 10 plus signs, okay? So you will not need to do this on every problem, but it helps us visually understand what's happening. So positive 10. So I'm going to draw 10 plus signs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And then we have plus negative 6. We have negative 6, so we're going to put 6 negative signs. 1, 2, 3, 4, 5, 6. Okay? And we would say that a plus and a negative sign cancel each other out, right? One positive and one negative just goes to 0. So I'm going to match these all up. We have a plus and a negative. We have a plus and a negative, or a positive and a negative, positive and a negative, positive and a negative, positive and a negative, positive and a negative. So those all cancel each other out, right? If we have one positive and one negative, it goes to 0. So these all cancel each other out. What we have left over is 1, 2, 3, 4 positives. 4 positives. So we would say equals positive 4. So 10 plus a negative 6 equals a positive 4. This is one way that we can write out the problem so we can see it visually. Another way would be, guess what we've used the last 2 days? A number line. So let's try using a number line to find our answer. So where do I have room? Let's put it, I'm going to have to, we'll fit it up here. Okay, so if I draw my number line in, we'll get rid of our heading, that's what we'll do. If I draw my number line in, okay, and we need 10 and some space around that, so we'll put 0 down here. We're going to need a little more space. Okay, so we have 10, okay? So we are starting at 10. Then, and we can show that getting to 10, but we'll just say we're starting at 10. Then we add a -6. Now if it's a -6, will that be to the left or will that be to the right? If it's negative, it's getting smaller, so we would be going to the left. Okay, so we're going to go back 6. So 1, 2, 3, 4, 5, 6. So when we are at 10 and we go back 6, we end up at 4, which is what we got. Okay, so this is a way you can model what you're doing. Okay, when we say modeling, it's a visual representation of what's going on in this problem. Now, will you need to do this every time? Will you need to do this every time? No. Could you? Yeah. These are ways to help us understand what's going on, and the more confident we get, the less we need these representations, these models. All right, let's try another one. At the end of this lesson, we're going to come up with some rules together. Well, when I say together, I really mean me, but I want you to think about them, okay? So what about this one? What if they give us -7 plus 2? -7 plus 2. Again, I'm going to show you modeling this two different ways, okay? So two different visual representations. So if we have -7 plus 2, so we have a -7 and a +2. Let's use the plus and minus signs to represent this. So 7 is negative, so we'll have 7 negative signs. So 1, 2, 3, 4, 5, 6, 7, and 2 positive. So we'll say plus, plus. So this cancels out with this cancels out with this, and we're left with 1, 2, 3, 4, 5 negatives. So -7 plus 2 is negative, and how many were there? 5. So -5. -7 plus 2 is -5. And again, we can use a number line. If we draw our number line in, oh boy, I'm struggling. Okay, draw our number line in. We're starting at -7, so we'll put that in here. We might need a bigger number line. If we need more, you can always make it longer. And again, you can write one, draw a number line in at the top of your paper, and then just use your pencil to trace it and keep reusing it, okay? Or print one off. Starting at -7, okay, so here's -7. And we are going to add 2. Now, if we are adding 2, a +2, would that be going to the left or would that be going to the right? Well, if it's positive, it would be going to the right. So +2 would get us to -5, which is what we got here. Now, I do want to point out a few things because we're going to come up with some rules from this. Are these signs the same or different? They are different, right? What did we do with 7 and 2 to get 5? Well, it's really just subtraction, right? 7 minus 2 is 5. Now notice, it's a -5, and that's because 7 is negative. And there were more of those negatives, right? We're going to talk about why that is after a bit. Let's try a few more. Let's try this one. What about -3 plus -5? -3 plus -5. Let's use the plus and minus way to represent it. So we have -3, so 1, 2, 3. Then we have plus -5, so we have 1, 2, 3, 4, 5. Now my question is, does a negative cancel out a negative? Well, maybe in English it does, but it does not in adding, okay? So really, we just add all of these negatives up. None of them canceled each other out, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8. -8 is our answer. -3 plus a -5 is -8. Let's look at this on the number line. I want to teach you the systems and the processes, but before we get there, if we truly understand where these come from by using these different visual representations, the rules will make a lot more sense. All right, so we're going to start at -3 and we're going to add -5. So we're going to need some room here. I don't know what to do. Let's see. -3, -2, -1. Make sure you're making your number line in the correct order. Positives go to the right, and larger numbers go to the right, smaller to the left. Okay, so -3 plus -5. So -3 is right here. Now, if we add a -5, if we're adding a -5, will that go to the, now I have some students get confused, is it positive or negative? It is adding a negative number. The 5 is negative, okay? So a -5, will that go to the left or will that go to the right? Well, if it's a -5, that's going to be to the left. So we're going to go back 5. So 1, 2, 3, 4, 5, and we'll end up at -8, which is matching what we had before. Now notice here, these have the same sign, -3 and -5. When they have the same signs, we don't subtract, we do what? We add them up, and we're going to use that to help us. So, based on everything you've seen, if we were in class, I'd spend a little more time trying to draw this out of you, and we could come up with it together, but I'm going to give it to you now. So, write this down. These are really helpful rules, and it just reflects what we've been seeing, okay? If the two numbers have same signs, we would say add and keep the sign. So on the last one where we had -3 plus -5, the signs are the same. They're both negative numbers. So we would say, we would just add them without the sign. So 3 plus 5 would be 8, and we keep the sign. Since these were both negative, it'll stay -8. Another example of this would be one that we're very familiar with. If they have the same signs, they can also both be positive, right? If they're both positive, you add them. So 2 and 7 give us 9, and keep the sign. Since they're both positive, our answer is also positive. So if they have the same signs, that means they're both negative, or they're both positive. We add up the numbers and keep the sign. All right, what if the signs are different? Let's come up with a rule for them. And if you need to rewind and pause that to get those notes, do that. Different signs. So that means a positive plus a negative, or a negative plus a positive. Okay, different signs. If you have different signs, you subtract and keep the sign of the number with the greater absolute value. We'll talk about what this means. Give you a little bit of time to write it, and then we're going to do some examples and we'll be finished. If we are adding with different signs, we subtract and keep the sign of the number with the greater absolute value. Now, I'm not even going to show you a different example. Let's go back to our very first one. 10 plus -6. First of all, can we all agree these have different signs? Positive, negative. Okay, different signs. With that in mind, we are going to subtract. What is 10 minus 6? Well, it is 4. Then it said, keep the sign of the number with the greater absolute value. So between 10 and -6, which one has a greater absolute value? Now remember, greater absolute value. We learned about absolute value yesterday. That's the distance from 0. And that just means we make them both positive. So which one is greater, 10 or 6? Well, 10 is. And since 10 is positive, that's the sign we're going to use here, positive. Do we put a plus sign? No. No sign signifies positive. Okay, let's try one more example with different signs. What if we look at this one? -7 plus 2. I think this is another one we already looked at, but it's kind of helpful to think about them again. First of all, do these have same or different signs? It has different, right? This is a -7, +2, so one's negative, one's positive. So we're going to use these rules. If they were both, if this was -7 plus -2, they'd be same, and we'd add them and keep the negative sign, but they're different. So it says subtract. So what's the difference between 7 and 2? Well, it's 5. And then we keep the sign of the number with the greater absolute value. So between -7 and 2, what's the absolute value of -7? Well, it's 7. Absolute value of 2 is 2. So what's greater, 7 or 2? Well, 7. And 7 in this case is negative. So our answer will be negative. If you're struggling with any of these rules, use the rule and then use one of those modeling techniques like the number line or the positive and negative signs to go back and check your work. So your homework today looks like this. Okay. We have 2 integers being added all throughout except 8 and 9. 8 and 9 are optional. It would be fun for you to give them a try, but I am only grading 1 through 7. Have a good day, and tomorrow you will just be reviewing what you learned this week. So have a great rest of your week.